Since its launch on the 25th of December 2021, the James Webb Telescope has achieved unprecedented success in the world beyond. And it is not done yet. On the contrary, this iconic space observatory tool has continued to make mind-blowing discoveries, including one that revealed the most distant and earliest galaxies scientists have ever seen. But what exactly did we learn from these discoveries? And what implications does it have for our planet? Let's find out. As the most powerful space telescope ever invented, the James Webb Telescope is the most relevant gadget in the world of astronomy, not just at the moment, but in the history of the industry in its entirety. This advanced cosmic machine is a scientific phenomenon that is about 5 to 10 times superior to its predecessors. And as such, it has made groundbreaking discoveries that were deemed impossible in the past. This includes exciting astrophysical elements like Einstein's rings, new exoplanets, and more recently, the most distant and earliest galaxies we've ever seen. This phenomenon was announced by an international team of astronomers using data from the James Webb Space Telescope. According to experts, the light from these galaxies has travelled over 13.4 billion years to reach us. This suggests that the galaxies were formed approximately 400 million years after the Big Bang. Initial data from Webb insinuated that such planetary elements exist. But critically, this is the first time we are getting confirmed reports of their existence. And that's thanks to the spectroscopic observation, which has revealed characteristics and distinctive patterns in the footprints of the light emanating from these incredibly faint galaxies. It was crucial to prove that these galaxies do indeed inhabit the early universe. It's very possible for closer galaxies to masquerade as very distant galaxies, famous astronomer Emma Curtis-Lake from the University of Hertfordshire in the United Kingdom said. Seeing the spectrum revealed as we hoped, confirming these galaxies as being at the true edge of our view, some further away than Hubble could see. It is a tremendously exciting achievement for the mission, he added. At the centre of these discoveries were unified efforts and the collaboration from scientists who pioneered the development of two critical instruments on the James Webb Telescope, which are the Near-Infrared Camera, NIRCam, and the Near-Infrared Spectrograph, NIRSpec. Interestingly, the possibility of finding these elements fueled the development of these instruments. As such, during the consultation and development process, the instrument team put forward the JSWT Advanced Deep Extragalactic Survey, JADES. This ambitious international collaboration saw over 80 astronomers from 10 countries exchange ideas in a bid to develop advanced equipment and methods that would reveal in-depth information about the earliest periods of our universe. And just over 1 year since the James Webb Telescope was launched, we are reaping the rewards of their work. Initially, the first round of discussions and conservation made by the JADES team was centred around the Hubble Space Telescope's ultra-deep field. This region of the sky has been one area that has caught the interest of astronomers over the years. And as a result of this keen interest, many of the world's most advanced telescopes have toiled the region in search for data, objects, elements, and any information they can gather. Of course, the Hubble Space Telescope, being one of the most advanced space observatory tools, has been able to make some exciting discoveries within and outside the ultra-deep field. This includes a sensitive data set spanning the full electromagnetic spectrum. But with the ultra-advanced James Webb Telescope coming into the scene, we are bound to see more interesting views of not just this area, but other regions of space. These galaxies are well beyond what we could have imagined finding before JWST. Brant Robertson, an astrophysicist at the University of California, Santa Cruz, and one of the researchers involved in the observations, said in a statement, "With JWST, for the first time, we can now find such distant galaxies and then confirm spectroscopically that they really are that far away." Again, we must emphasise that all of these successes are all down to the incredible work done by scientists and astronomers during the JADES program. Initially, the program began with the NIRCam instrument. From this phase of the program, they spent a total of 10 days observing the field in 9 different infrared colours and producing high-quality images of the sky. Eventually, they created a stunning image that is about 15 times larger than the deepest infrared images produced by the Hubble Space Telescope. Admittedly, the image generated by Webb was much deeper and sharper at these wavelengths and only about the size of a human when viewed from a mile away. But make no mistake, the portrait is embedded with thousands of astrophysical elements. At the very least, the image is believed to contain nearly 100,000 galaxies, each captured at some moment in their history billions of years in the past. For the first time, we have discovered galaxies only 350 million years after the Big Bang, and we can be absolutely confident of their fantastic distances, Brant Robertson added. To find these early galaxies in such stunning, beautiful images is a special experience. Thanks to these exquisite images, we are able to accurately distinguish the galaxies in the early universe by a telltale aspect of their multi-wavelength colours. Generally, we know that light is stretched in wavelengths as the universe expands. Hence, astronomers look out for faint galaxies that are visible in the infrared, but whose light abruptly trips off at critical wavelengths. In the case of these early galaxies, scientists discovered that their lights had been stretched by a factor of up to 14. Critically, the location of the cutoff within each galaxy's spectrum is shifted by the universe's expansion. For this reason, the JADES team searched the Webb image extensively, looking for these distinctive candidates. Subsequently, they deployed the NERC-SPEC instrument to observe for a brief period that lasted for about 3 days. During this period, scientists actively collected useful data for 28 hours. In all, data was collected from 250 faint galaxies, and this allowed astronomers to study and further understand the patterns imprinted on the spectrum by the atoms in each galaxy. More importantly, it gave us a precise redshift measurement of each galaxy. And lastly, it helped us learn the properties of the gas and stars in these galaxies. As we've come to understand, the universe is expanding, and it has been like that since the beginning of time, and it's not about to end anytime soon. Due to this expansion, light travelling through space is stretched extensively in a phenomenon known as cosmological redshift. This works in such a way that the greater the redshift, the greater the distance the light has travelled. As a result of this phenomenon, scientists and astronomers need telescopes with infrared detectors to see the light from the first and most distant galaxies. These are by far the faintest infrared spectra ever taken, prominent astronomer and co-author Stefano Carniani from Scuola Normale Superiore in Italy said. They reveal what we hope to see, a precise measurement of the cut-off wavelength of light due to the scattering of intergalactic hydrogen. 2 of the 4 discovered distant and earliest galaxies lie at redshift 13. Nonetheless, all of them are deemed exceptional, mainly because of their distance and faint nature. And thanks to the exquisite sensitivity and advanced capability of the James Webb Telescope, astronomers will be able to explore these rare celestial elements even better. Sandro Tacchella from the University of Cambridge in the United Kingdom emphasised this in a statement made recently. It is hard to understand galaxies without understanding their initial development periods. So much of what happens later depends on the impact of these early generations of stars. So many questions about galaxies have been waiting for the transformative opportunity of Webb, and we're thrilled to be able to play a part in revealing this story. In the meantime, the JADES program will continue to run in 2023 with a detailed study of another field. The organisers intend to start around the iconic Hubble Deep Field before moving on to the Ultra Deep Field to perform a fresh round of deep imaging and spectroscopy. But, of course, there are many more candidates in the field awaiting spectroscopic investigation, with additional time already been approved for some of them already.